Hi, I'm Scott Baker. I'm an arborist here in Seattle, and before we go outside and look at a real tree, I'm going to explain to you briefly how the ArborSonic tomograph works. The principle behind the machine is the measurement of a sound wave through the trunk of the tree. And we know that when a sound wave travels through a consistent medium, like solid wood, it will have a consistent transit time. And we know the transit time for different types of wood. So, if you have a sensor on one side of the tree and the other, and you generate a sound wave, the tree is solid, the sensor will generate the sound wave and the sound will travel directly to the sensor on the other part of the tree. If there is a void or a different medium, and that would be decayed wood, the sensor generates the sound wave, but the sound wave must take a longer time to get to the other side of the tree. I'm going to explain to you a little bit about the principle behind the acoustic tomograph. So the way the ArborSonic tomograph works is these little sensors are placed around the tree. And they're actually a sensor and a receiver. So when they're tapped, they're transmitting a sound, and all the rest of the sensors around the circumference of the tree are picking up that sound wave. So here's an illustration from the ArborSonic manual where you can see the sensors placed circumferentially around the tree. And in this picture, you see the colored image that the tomograph creates and the picture of the tree that we're looking at. And this tree has a hollow center, decayed center. So basically, what we're doing is measuring the time it takes for sound to travel from one pin to the next. And when we're tapping on sensor number 1, we're getting the sound time to sensor 2, to sensor 3, to sensor 4, sensor 5, and so on around the trunk of the tree. So the principle is that if the tree is solid, then the medium that the sound is transmitting through is all the same. And we know the expected flight time for particular types of wood, and so we can say if between sensor 1 and sensor 2 is a meter, and the flight time should be x, we can say that if you get the time that you expect, the wood is sound. If, however, the tree has a hollow or a decay in the middle of it, the sound wave is going to have to go around, and thus the flight time is going to go longer. And I'm going to explain to you how the ArborSonic tomograph works. So you can see here we are on the first screen of the software, and it's labeled tree, and this contains the tree properties. So you can put in your project identifier, other important information about the location of the tree. At the top here, the bar that's blue right now is the species drop-down menu. I have a number of species that we commonly see here in Seattle loaded in there for quick access. There's also several thousand tree species also available to pull out for your particular use. Then as you drop down, the software also has an area where you can record the status of the various parts of the tree, the root collar, the crown of the tree, the trunk of the tree, and so on. And then below that, you can propose treatments for the tree. And all this information will be relayed into the reporting at the end of the process. So I'm measuring the tree. This tree is basically elliptical in shape. And what I'm doing here is just figuring out the dimensions of my ellipse. I have 71 centimeters in that direction and 58 in this direction. Okay, so there are 3 choices here for the shape of the tree. You can choose a circular shape, an elliptical shape, or an irregular shape. And today I've chosen elliptical shape as our tree is elliptical in shape. And I've made some measurements with a manual caliper to determine that the dimensions on the 2 axes, the long axis of the ellipse and the short axis, and I've entered those in here, 71 centimeters by 58. And then I also have a place to enter the circumference of the tree, which I've measured here at 216 centimeters, so that dimension goes in. So here we are, I've measured the tree, and I've recorded some of the information about the shape of the tree into the sensor geometry screen. So I've chosen an elliptical shape, I've put in the long axis and the short axis of the ellipse, the circumference of the tree, and then the computer makes a picture of that ellipse and places the 10 sensors at regular intervals around the tree. These are labeled with a dimension along the top of the screen. The next step is to place the sensors into the tree. I'm holding one of the sensors here. You can see the pin that's inserted into the tree, the head that you use to drive the sensor in, and that also is used to generate the sound, and then what I call the cable tail. And again, this portion of the sensor is not to be used as a lever or a handle. All manipulation of the sensor should occur holding the head of the pin, like I am right here. And you can see that we've numbered our sensors with a marking pen on the top, and they're also numbered with a little letter on the cable. All the sensors are identical, but it's very helpful to keep everything in numeric order when you deploy it on the tree. I've laid out the sensors on the tree according to the computer, and I've also estimated the thickness of the bark on the tree, that is the BT field on the computer screen, as in this case 1 centimeter, and I've also estimated the penetration of the sensor into the wood of the tree, which I think will be about 1.5 centimeters in this case. So now I have all the information entered into the tree, and now I'm going to set the sensors. So using the rubber mallet, we set the pin in the tree, and it needs to be in there so that with 3 fingers I can't turn it. In other words, it's firmly set in the wood of the tree. When you're messing with these sensors, you do not want to put any force on the bottom. Don't use the cable tail as a handle. Use the head of the sensor to handle the sensor. So I'm just going to make my way around the tree, making sure all the sensors are properly set. Okay, the next step is to connect the amplifier boxes in series all the way around the tree. The boxes are labeled, and they must be in numeric sequence around the tree. This is the reason why it's helpful to keep your pins in numeric order, even though they're interchangeable. So now I've got box 3, 4. These little connectors are a quick connect. They're very easy. There's no forcing involved. Very simple. The next step is to cable them together. So the cable sequence is signal out, signal in. So for box number 1, signal out would be at the side. The little connector has a groove that guides it. The groove is on the label side of the box. Once again, the cables should fit together smoothly. There should be no need to push or force. So bottom in, and then side out. So we're all ready with the sensors deployed. I've turned on the Bluetooth box, and I have the green bar that's reading. Now I'm going to begin tapping the sensors, and my data, the time signals, are going to come up in rows beneath the sensors. Now the tapping is important to do it in a real consistent manner. You want to just gently let the hammerhead make contact and then rebound quickly off the sensor. And when I do it, there's a signal tone that comes through on the computer. So let's give it a whirl. Three taps per sensor is fine. And if you want to look at the data rows here, you can see that they're all coming up with a green dot, meaning that the transmission times are good and the standard error is within the limits of the device. So sensor 2. Okay, so I've got all my data. There's no large errors in the time transmission, so the computer is saying that I've got a good data set here. Many transmission times from all the sensors. And so I can move over to the next tab and produce the image of the tomograph. So here's our tree. And this tree clearly has a good sized hollow in it. This species of tree is very decay resistant, and even though it's fairly significant in this case, it's not really worrisome for me with this particular tree. Okay, now we're looking at the tomograph image on the tomograms page of the software here. There's a number of different ways to display the image. Right now I have it in a two-dimensional or 2D image. And it's very easy to see that between sensor 5 and 7 we can see that there's a void or an area of decayed or different material in the tree. And in this tree we can see that that's obviously the case, and that our test is very consistent with what we can see visually outside the tree. If we go to the graph, I find this very interesting, and I think this is a great way to help people understand how the tomograph works. These lines with the color coding, which is, by the way, the same color coding as the image of the tomograph, with the decay in our case showing as blue and the good wood showing as green. And here you can see the time transit measurements expressed in a graphic form, and the color coding shows you between which sensors the slow times occurred. Okay, I've decided to make another measurement of the tree, make another layer. In this case, I've decided to go down towards the flare of the tree, and I've laid my sensors in a regular order around the tree, and I've placed them based on the anatomy of the tree. So, we've chosen the irregular shape on our sensor geometry page in the software, and so this means we have to measure the tree. We do that by measuring between sensor number 1 and sensor number 2, and then entering that measurement into the computer. Then we're going to continue to measure from sensor number 1 to sensor 3 with the caliper, and to sensor 4. And then once we've done sensor 1 through 10, we'll then move to sensor 6 and measure from sensor 6 to sensor 2 to sensor 3, 4, 5, 6, and so on around the tree. And we'll enter all that data manually into the computer. There is a Bluetooth caliper available as an accessory for the ArborSonic, which is a marvelous device. It speeds up this process quite a bit, and the caliper is also articulated, so it makes it a little easier to get accurate measurements from a very irregular tree base. We've made all the measurements around the layer at the base of the tree here, and the computer has drawn us an approximate picture of that shape. And so that is the shape that the sound waves are going to be transmitted through. And so again, we just move over to our time data screen, and same drill as last time. Turn on the battery box with the Bluetooth, wait for the bar at the top of the screen to go green. Green it is, and then we go and start tapping. So again, remember, very light tap. And oh, gee, look, this is loose. So I've got a loose sensor here. I didn't tap it in quite enough. It's very important never to tap on that sensor with the amplifier box attached. So do not tap on the sensor with the amplifier box attached. And now I can give it a couple of whacks, and there it is. It's firm now. You might have heard that ding. That ding was one of the other sensors picking up my tapping, and so it's recorded on the machine. I'm going to remove that row right now, and there is a tab here that says remove bad rows, and that sound that was picked up did come up on the data screen here as not good data. So I'm going to hit remove bad rows. Now I'm ready to start again with my tapping. Here we are looking at the tree, and sensor number 6 right here, sensor 7, sensor 5. And so this particular test here gave me a very accurate representation of the opening in the tree, and it shows a very thin wall on the rib that's forming as this tissue rolls across the old wound on the tree. So when you do this, it's very important to stay consistent with the way you deploy your sensors. So today, I used the north compass direction to place sensor number 1. And we've found that it's a good protocol just to always do that. It helps you to remember when you're back at the office trying to visualize what you did, to know what you did. We also generally take a still photograph of the setup, which is also sometimes helpful when you're back at the office. Occasionally, you'll find that the sensor pins are into the tree too tight to be easily removed. And so rather than take the chance of tweaking the cable at the bottom end of the sensor, ArborSonic has provided this little slide hammer, which just allows you an easy method to get that sensor out safely. Another thing I wanted to show is a long sensor here. This is about 3 times the size of the standard sensor. And FACOP made these up at my request, actually, because out here in the Northwest and in many other places we have trees with very thick bark. And even with this long sensor, in some tree species, you may have to do a little manipulation of the bark to enable your pin to get into the wood of the tree, into the xylem of the tree. So the long sensor for thick bark trees, and the slide hammer for easy removal of the pins. So there you go, the ArborSonic Tomograph, and we'll be back with more.